So here we have the notes for section P6, complex numbers. So the number I equals root negative 1 is defined as a solution of the equation I squared plus 1 equals 0 and is referred to as the imaginary unit. Therefore, for any real number a, the opposite value, the square root of a is equal to the opposite value of a times I. So if you need to take a negative root, you pull an I out for side and then do the root just like you normally would. So here we have a complex number. So complex number is any number written in the form a plus bi, where a and b are real numbers. Now the real number a is the real part, the real number b is the imaginary part, and a plus bi is the standard form. So a real number a is technically a complex number, it just has a b value of 0. And then imaginary numbers are the reverse. If a is 0 and b is not, then you have just bi, which is an imaginary number. All right, so operations with complex numbers. So here we have addition and subtraction. So addition and subtraction with complex numbers are actually just like terms problems. So collect numbers with numbers and i's with i's. So 7 plus 4 is going to be 11. Negative 3 plus 5 is 2. So 11 plus 2i. For the subtraction one, similar thing. So 2 minus 8 is 6. Negative I minus 3i is negative 4i. All right, so on the back side here, we have multiplication, which is actually a FOIL problem. So we're going to multiply those. So firsts would give me 10. Outsides would give me minus 2i. Insides would give me positive 15i. And lasts would give me negative 3i squared. Now, the thing is, this I squared is equal to negative 1. So this is actually negative 3 times negative 1. So that's 10 minus 2i plus 15i plus 3. Because this negative 1, when it multiplies with the negative 3, flips the sign. And now I do my like terms. That's the 2. So 10 plus 3 is 13, and that is 13i. So example 3 is similar. Given that z is this, find z squared and z cubed. So we'll start with z squared. So that is that. So z squared means you have 2 copies of the parentheses. So I'm going to need to FOIL these guys together. So firsts would be 1/4. Outsides, root 3 over 4i. Insides, root 3 over 4i. And lasts, 3/4 I squared. When you multiply a root by a root, the number just comes out. So root 3 times root 3 on top is 3. So this is equal to negative 1. So this is actually, I'm going to cross that guy out, just change this sign to negative. So that's negative 1/2, 1/4 minus 3/4. And then this is plus root 3 over 2i. This becomes 2 root 3 over 4, which will reduce. So there's z squared. So to get z cubed, I'm going to take my answer to z squared and just multiply by another z. And just repeat the process, because z cubed is z squared times z. So firsts be negative 1/4. Outsides, negative root 3 over 4i. Insides, positive root 3 over 4i. And lasts, positive 3/4 I squared. So these two in the middle will drop because they have opposite signs. This is negative 1, which makes it disappear, and this just becomes a minus. So negative 1/4 minus 3/4 is negative 1. All right, so to do division, we use what's referred as the conjugate. So the conjugate just has the opposite sign in between, and you multiply. What happens is the top and bottom get multiplied by the conjugate. So here I have 3 minus i, so its conjugate is 3 plus i. I do that on the top and the bottom. So the top is just distributing. 2 times 3 is 6, 2 times I is 2i. The bottom is a FOIL. So firsts are going to give me 9, outsides positive 3i, insides negative 3i, and lasts negative I squared. So this is 6 plus 2i over 9. Now those cancel. Now negative I squared has become positive 1 because the I squared flips the sign and then it disappears, leaving the 1 coefficient behind. So this is 6 plus 2i over 10. All of these numbers are even, so I can take a 2 out of everything, leaving me that. All right, so the second one, similar thing. So the conjugate for this one is going to be 2 plus 3i. So on top, this is now a FOIL. So firsts are 10, outsides are 15i, insides are 2i, and lasts are 3i squared. On the bottom, 4 plus 6i minus 6i minus 9i squared. Now remember, these are going to flip the signs. So I'm going to just fix that now. So this whole thing becomes -3. That whole thing becomes +9. And then it's like terms. So that's 7, 10 minus 3, plus 17i, all over 13. Now, if you notice, if you've done the conjugate right, these middle two terms should always drop out. And that's the whole point of doing the conjugate, is to make those I terms go away. Okay. So example 5 over here, we've got complex solutions to the quadratic. So you can have 3 actually different things can happen when you use the quadratic formula. If the stuff underneath the root, referred to as the discriminant, is greater than 0, you'll get 2 separate solutions. If it's equal to 0, you get 1 solution, and if it's less than 0, you get a complex solution. So we'll try it on this guy. So A is 1, B is 1, C is 1. So the quadratic is -b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So that's -1 plus or minus the square root of 1 minus 4 over 2. -1 plus or minus the square root of -3 over 2. Now you can't take the square root of a negative number, but what I can do is I can pull an I out front. That makes the root now be positive. That's as far as I can go on this one. If that was a larger number, I'd try to do a factor tree on it, but since it isn't, there's no really point in doing that. And that looks like that's the end of the section.